Hello, welcome to... That was a weird hello. I wasn't expecting a hello to come out like that. Never mind, it did. Anyway, welcome to the Sunday Science Q&A, which is live as usual. Last weekend, of course, we didn't do it. That was because we did that show in the evening about the sea, basically, the oceans and the mysteries within, the things we do know, the things that we are hoping to find out. We did see Shambles, and we had so much fun. And I thank you, everyone who watched that. We had far more people watching it than could have fitted in 5 Albert Halls. So it was great to have everyone and have Chris Hadfield joining us and all of those other wonderful things. So thank you very much for that. I have a few things to tell you. One is that my frequent compadre Josie Long, she is doing her show Tender tonight at 8:30. That's a live stream show of the show that she would have been taking on tour, that she's been doing every now and again. It's a lovely show, and it's always interesting to see the different ways that Josie reacts, because of course for all of us, when we're actually performing now and we're basically just sat at a table as opposed to showing off in front of a few hundred people in Exeter Phoenix Arts Centre, things are very, very different. So I highly recommend you watch that. I think there's normally, I'm not sure if today there is, normally there's a tip jar at the bottom of here. We've been using the money that we've raised from various shows that we've been doing to spread amongst artists and also some of the art centres that are also in jeopardy at the moment. And also we've started a Patreon now as well. We've got a new Cosmic Shambles Patreon, which is going to cover all of the new shows that we're doing. Next week we're doing a show and tell. I think on Tuesday we're going to do a show and tell with Ralph Little, where he's going to have various different things from his career and things that he's done. On Wednesday I'm going to be doing my I'm a Joke and So Are You show, which is a show based around my book of the same name, and I'll be doing a Q&A after that as well. We're also going to be showing part 2 of the film that Helen made with European Space Agency, with Ginny as well, and with Tim Peake. That's also on Wednesday, and then you can catch up with that if you want. There's loads of things coming out. Anyway, so that's what we're using the Patreon money for, just in case you wanted to know. We've had lots of brilliant questions. I'm going to check. There'll be things I've forgotten off the admin, and Trent will be furious. But it doesn't matter. We can pick up on that later on, because we have such great panelists. I'm not sure how many have a show and tell, but we will find out. Just I know someone who will definitely have a show and tell, because they've been rummaging through boxes basically for the whole of this week. It was my co-host from Sea Shambles, and on this every week as well. Helen Czerski, what have you got this week for us?
What have I dug out of the bottom of my wardrobe? Okay, so this week, this one, it's a little pot, and I'm going to hold it up to the camera so you can see what it is. And it says sea salt of, is it Hawaii or Kona? Hawaii. And the reason I am showing you this sea salt here is because this made me very excited. Fundamentally, it is exactly the same as any other sea salt. But let me tell you where it comes from. There's a place in Hawaii, obviously haven't been there for a while, can't go for a while, but I wouldn't go because of the carbon footprint, but where they pump cold water out of the deep ocean from 1 kilometre deep, and then from the surface water, because in Hawaii it's nice and warm, they pump 30-degree water. So they've basically got a hot tap and a cold tap to the ocean, which I just think is brilliant. And even better than that, they paint the pipes red and blue, so you can tell which one is the hot tap and which one is the cold tap, and they do all kinds of exciting things with that. But the sea salt is sea salt which has come from the deeper water, so it's come from 1,000 kilometers down. But fundamentally, and I knew this when I bought it, because, you know, this was not a cheap little pot of salt. It's really expensive because sea salt is pretty much the same everywhere. So it doesn't matter where your sea salt comes from. It has this it's a characteristic that wherever you are in the ocean, even if there's a little bit more salt or a little bit less, it's exactly the same. So I'm showing you this because I found it and I was embarrassed about how much I paid for it, because it is exactly the same as any other sea salt. However, as an oceanographer, it's very exciting because it did come from 1,000 kilometers down, from water that probably hasn't seen the surface for hundreds of years. So this is my show and tell for today.
And do you get, I mean, because I think, when we were talking with Chris Jackson the other week, and we were talking about rocks, and we were talking about there is something which is not scientific in terms of a rigorous equation that can be attached to it. But I think there is something emotional. There is something which at times can be transcendent when you, for instance, are touching that salt and you think about the journey of that salt, that there is a story that comes from that.
Because you feel human, connected to your science, right? Is that there's all this stuff, you do, if you learn science, you learn 2 things. You learn facts, which is what we teach, when really the more important part of science as a human is the perspective. And the times when you touch the object are when you touch the perspective. You touch the rock and you close your eyes and your mind imagines, you build in your mind your relationship, the perspective it gives you on the world. And it's like having binoculars or something, or they're not binoculars that look down, they're binoculars that look out. And so the objects are really important because it's like the back of the wardrobe in Narnia. You holding on to them takes you into the world that your mind can see but your eyes can't see, but all the knowledge in your head paints that picture for you. And it's an amazing, the objects really do matter.
How worrying that you've ended up using a Jesus allegory story there to attach to that. There'll be people sending in complaints already. We're also joined. It's always lovely when we have people that I haven't met before, but are at the forefront of the work they do. Joined by Anne-Marie Imafidon. I'm very, very pleased to have you here. You are a STEMette. Mathematician, computer science, but on top of that, you had 11 years old. You got your maths A level. Is that right? Oh, you're on mute, I think, or I'm on mute.
I am maths and computing A level. So I was on mute
because that is it was made you extremely enigmatic, though. It was at points I thought, should I say anything, because I'm still getting part of the story. But that is. What was it? Is there anything you can pinpoint, any part of your growing up that you found that attachment to those kind of ideas, which, of course, as we know, people feel quite happy to say, I don't really get maths. And I know it's a lot of hard work for someone, going out there to encourage people to do maths. And to have achieved that at 11, what do you think in your upbringing or story attach you to those ideas?
So what attached me? So the short answer to that is I did the GCSEs the year before, and kind of you do A levels after you've done your GCSEs. But I think the longer answer on that is with maths and with computer science in particular, they're incredibly logical, and so they were very reliable. Where human beings, and sometimes science, wasn't as reliable as maths is, and as computer science can be. So I think for me it was, if I've written this code, it's going to act the same way as if anyone else had written the same line of code. And the same with maths. There's something true about it and consistent that you don't really find anywhere else.
I was having a conversation with Brian Greene the other day, and in his latest book, Until the End of Time, there's a lovely moment. He goes, just every now and again, he has a little moment where he thinks, what even when the extraterrestrials arrive, the first thing they say is, oh, maths. We used to think that was the language of the universe too.
And then involved. So yeah.
Now, I'll just also ask you about STEMettes. What is STEMettes?
So STEMettes is we're a social enterprise, and we work with girls and young women to encourage them into science, technology, engineering, and maths. So we run programs, we run events, we have an online platform, we have apps, we have a really popping Twitter account as well. And we're about three things. Everything we do is free to attend. Everything we do is fun to be at, and there's always food. And so we're struggling a little bit now with lockdown with our events, trying to get food out to people. I'm kind of missing that. We've got all these sweets in the office that no one is eating and no one is touching. And I think about them continuously. But that's what we're about at the STEMettes.
No, I know, but that does now. It's a bit like sometimes when I think about the Tate Britain and I think of the Aubrey Beardsley exhibition that no one can see, but you've really upped the ante now to me. See this box of celebrations, perhaps dangerously near its sell-by date. Perhaps
we've got hundreds of candy kittens in little sachets because they're vegan, so anyone can have them as long as you can eat sugar, I guess. And they are all sat there doing nothing, and it's one of the sad things in life at the moment of lockdown.
But you've been really active, haven't you, STEMet's email list, even though I suppose I'm a bit past it from your point of view. But these enthusiastic little emails turn up every week that say, oh, we're doing all this stuff, and it's so impressive. So well done you for keeping up that enthusiasm while everyone's shut away.
Well, thank you. I think it was naivety more than anything else. We decided to do 12 weeks of, we've called them STEM mode in, because we normally say turn your STEM mode on. So this is bring it in. We've done 12 weeks. Actually, no, next week is week 10 of 3 events every week. And we've had all kinds of different people on, from GCHQ doing Arabic sessions and talking about what they do, to Just Eat we had on Friday. We've got some scientists as well on our Instagram Live on this Friday coming. So we've had lots of different people. We've done engineering, computer aided design. So we've done lots. I think, if I was going to go back to the beginning, I would have maybe chosen 8 weeks. Or 6 weeks instead of 12. But But no, thank you. It's been really good, and the girls have been really regular and joining in. So it's been really nice to keep some of that vibe going. Alas, without the food. I have an object.
Brilliant. The show and tell, please do.
So I want to show you this object, and it's a little bit promo-y, but this is you're the first people to see it in my hands. So I have a book out. This is my first ever main book, I guess, with Dorling Kindersley, which is How to Be a Maths Whiz. And I've brought it along because it just arrived, and it's kind of exciting to see it in real life. Helen, you'll know this. You've published so much. Kind of, you have all the PDFs and the words and the things that go up and down with your editor, and this is it in real life, in my hands, in the flesh. But also, I spotted one of the questions that was submitted was about marble runs, and I've got I've got 2 double-page spreads on marble runs, so I'm looking forward to helping to answer the marble run question for later.
I will throw that question to you first of all. Do not worry. Yes.
That is brilliant for many reasons, but mostly I remember time I think I spoke to you in person. We shared a taxi at the Hay Literary Festival, and I'm the only person here that hasn't written a book, and now you've written a book. So it's
I know, yay! It is here, and it's real, and it's in the flesh. So yeah, thanks for remembering. That was a cool taxi ride. Yeah.
Did you have one of those weird moments where there was someone else at the station who was like, I remember the first or second time I did Hay, Martin Amis was there as well, looking quite tetchy. And my friend who was with me, Martin White, who's an accordionist, he said, I'm a huge fan of Martin Amis, so I'm going to have to go up to him. And his opening line to Martin Amis to win him over was, hello, my name's Martin too. They never saw each other again. Now we're also joined by Suzie Imber as well. How are you, Suzie?
Hi, very well, thank you, very well.
I know you have at least one show and tell. You have a cup of tea, don't you?
I have a cup of tea. Yes, I did sneak off and make this, a fresh cup of tea. And actually, I was just looking for a book. There was a book I wanted to show and tell, but I can't find it. I've got stacks of books everywhere. Called The Worst Journey in the World by Apsley Cherry Gerard. Has everyone read that book? I don't know if you guys have read it.
It is brilliant and dreadful.
Actually, so I read it first years and years and years ago, and I've read it since. It's about an expedition in Antarctica, basically, and kind of all the terrible hardship that these people go through. And the really sad part is that towards the end of the book, I don't know if you remember this, Helen, but at the very end, it's about Scott's expedition. And you know what's going to happen because you know the ending. So it's just kind of filled me with dread at the end as I got to the end. But it's a really interesting book. And it's my show and tell because it could always be worse, I think.
Well, the thing was that Scott dying wasn't the worst bit. That he's right. They were doing science. They were going. Was it seeing penguins or something? There was a penguin
eggs. They were collecting emperor penguin eggs. Yes, from a really remote place. And they talk about things like having to get up in the morning and sort of get into the right pose for pulling their sledges because their clothes would freeze solid. And so they have to strike their pose. Everything freezes, and then they keep moving their legs, but their upper body and torso basically has to stay in the same shape for the hours of pulling the sledge until they can break the ice when they get to where they're going. Just horrendous. So yeah.
So we mentioned we briefly mentioned that Chris Hadfield was on the Albert Hall show that we did last week, and you of course spent a lengthy amount of time with him when you did the show Have You Got What It Takes, which you won as far as I remember, didn't you?
Yeah.
Now, there are so many people who are still, in fact, I would say more excited than they have been for a long period of time. I think space exploration and our potential to go there, it has become reignited. I mean, when Brian and I were doing the tour we did last year, you would get kids turning up in these fantastically homemade, the Apollo 11 kit, and sometimes, the stuff that the ISS kit, all that stuff. So what attracted you to that, the idea of space exploration? Because you're a planetary scientist as well. So I imagine from quite an early age you were attracted.
I was much more of an explorer than a scientist, actually, when I was a kid growing up, I have to say. So I really was totally enamoured by, that's when I started reading books about Antarctica, totally enamoured by the idea of exploration, going to new places. And space science, I just kind of tumbled into accidentally. I really liked it at university. I just kept studying it and ended up being a space scientist. And then sort of space exploration kind of brings those two things together, and that's why I think I'm really interested in human space flight, as well as the missions that I work on. The idea that genuinely explorers and that really appeals to me as a concept.
Because my sister loved that show. She's someone who just loves all. So again, she got all of that in terms of nature and nurture, the exploration thing, hey, I thought I'd do a 60-mile run and then you swim through a lake and then you do a cycle ride or whatever.
Yeah.
She's got all of that. I'm off to the library. But were the certain, because she, right from the start, I think she pinpointed you as being likely. There were certain people who went, no, they haven't got it. They haven't got the right thing. They seem very confident. They see, but there's something that's not. What do you think you understand now that you didn't at the beginning of the show in terms of what it psychologically takes to go into space?
I think the whole experience taught me a lot, actually. So although when I watched it, I've seen the series once. I saw it when it sort of showed on television. I haven't watched it since, but as I watched it through, there were lots of things that, as someone that was taking part in it, I couldn't see. So for me, every challenge that we did, every time they put you in front of the camera and say, "How did you do?" I feel like, oh, I'm going home. This is really hard. It's going to be me next, and I just felt like I was on the edge all the time, about to be kicked out. And only kind of with the hindsight of watching the show through did I realise actually I wouldn't fail everything, but it felt like I had, and partly because there was no perspective there. So. I thought I'd done really badly, but I didn't know how everyone else had done. And, it turns out some of them had done worse. Some of them had done better than me. So I think one of the things that it's hard to get across, actually, people often say, what's the hardest challenge? And there were some really hard challenges, don't get me wrong, super tricky. And I definitely messed up a whole load of them. But I think the hardest thing is, for us, was just week after week after week of challenge after challenge. We never got a break. We didn't go home. We didn't talk to or see family, friends, anyone, just being in this sort of bubble of testing. We did something like 44 challenges, I think, over about 5 weeks. So, and just silly things like, you wake up in the morning and you think, do I even want breakfast? Am I going to do a bleep test in 10 minutes? Or are you going to put me in a centrifuge and fly me around at 5G? Or are you going to test my emotional, you just don't know what's coming. And I think after weeks and weeks, it does kind of weigh you down. So sort of that really felt like one of the biggest challenges, I think, for all of us that got to the end.
I must see one day there was a show that the brilliant Kevin Fong did with Brian Blessed, where Brian Blessed went out to Russia to train to be an astronaut and insisted on doing tests where they went, generally men in their 60s, they just don't do this. I want to bloody do it. And then the first time we had Brian and Kevin Fong together on a radio show, Brian just stormed on stage and went, "That bastard nearly killed me." And it was just fantastic energy. I'm going to start off with, let's have the questions. I should mention, by the way, everyone who's watched this, we've got a whole back catalogue of these now, and we've also put out audio versions. Right, if you just want to listen to them, you can find them on loads of different kind of platforms now. Our science Q&As. I'm going to start with the marble question, because if I forget to do it, I'm going to have too much of a burden of guilt. So Anne-Marie, this is a question from Joe. This is Joe. Joe has been making marble runs from junk during lockdown and wants to know the best marble run tips from guests, and how close could he put his marble run to a black hole before it got sucked in, please. Now, this was so you don't have to, you could, first of all, you can just deal with in case you don't want to deal too much with singularity or indeed holographic principles and the fact the marble was two-dimensional all the time. If you don't want to deal with that, let's just start with structure of the marble run.
Yeah, structure of the marble run. As I've got here in the book, actually, ours is from kind of cut-offs and kind of cardboard. So I don't know how complex the marble run is that the person is speaking about. But as high as possible, as high as you can start and as low as you can end is going to give you the best velocity. So that's my tip. If you're going for speed, start incredibly high and end incredibly low. Black holes, I'm not sure.
Now, is there also, in terms of curves, in terms of what is possible, because quite often I've seen people do them and that they'll stick in a 90-degree thing and it's not going to happen. And I wonder in terms of angles as well, if there's any.
Yeah, don't do a right angle unless you've got something that's going to give it a lot of momentum to head off that right angle. Try not to do right angles. You want obtuse as much as possible. Yeah, have fun with it, I think. But start high as you can start. No right angles. Curves are good for building momentum, but again, you have to end your curve in the right place in order for the marble to kind of exit it really well. So I'd say that as well. But try an obtuse angle even within that curve, and you'll see you'll be flying. I go for speed. This is my thing.
It is such a joy, isn't it? When you actually have completed one, and after all the trials where it's gone wrong, and each little bit where the sellotapes had to be pulled out, and you've had to that joy of actually the momentum as it builds.
I think the process is also great. I think things getting stuck, it's quite funny and it's quite nice because you're almost, there's a chance at every point of failure, right? And so it's knowing where that failure is going to come next. I enjoy that, I think, more than even kind of completing it the first time or the second time. It's the process, it's the failures. Because sometimes you can surprise yourself, or gravity can surprise you. So that's always the fun ones as well.
That should be something that is.
I cannot believe, yeah.
That should be above every door of every. Just gravity can surprise you. I think that is it. It might be the weakest force in the universe, but I'll tell you what, it's got a few tricks up its sleeve. I'll ask you, Suzie, in terms of black holes. So the marble, what do we think? So it gets to the event horizon. Where are we seeing this is an amazing marble run that's been made to actually get to that black hole, obviously.
It's gone to the nearest black hole, so obviously if it crosses the event horizon, then we can't get it back again. But actually I think something that people often think about black holes, I think we imagine them as sort of, that disaster movie cartoon kind of thing where it's just sucking in everything and everything's just heading towards this black hole and destruction and things. Actually, if you're far enough away from a black hole outside the event horizon, then you can just orbit the black hole as though it was just a star in the center and you were a planet going around. So if your marble was quite a long way away from the black hole, it could just happily go around the black hole and not even realize it's a black hole, just something with a lot of gravity in the center of its orbit. So it kind of depends on the black hole, really, I suppose, and where you are.
That makes Earth sound like a marble. It makes Earth sound like a marble running round and round the black hole at the centre of the galaxy.
There you go.
They are. I've got to say, the black hole show we did the other day with Jan 11 and Sean Carroll. There's just bits where I know science is filled with things that are counter-instinctual, but there were 2 points in particular. I mean, the holographic principle. And it's anyway. Listen, it's going to be on next week. It was Matt Lucas was wonderful. I wish the audience at home would be able to see his apoplectic face as each theoretical physicist blew his mind a second time. It was wonderful. Helen, I'm going to ask you. This is from Caroline's daughter, who's 4 years old. Thank you very much, by the way. We've had loads of questions from kids today, which is wonderful. Caroline's daughter is 4 years old. Wants to know why a crystal sparkles when light hits it.
This is interesting. So crystals, not all crystals sparkle, but I think the sort of thing she's talking about is a diamond is a very good example. But there are other crystals that are transparent and colourless, and they have cut edges. And the interesting thing about crystals is that this sort of crystal, which is that light goes in and it can actually undergo something called total internal reflection on the inside. So we think as light going into glass and getting bent a bit, refracted, and then coming out the other side, and that can happen. But the other thing that can happen with a crystal is that it's like if you look down into a pond, you see straight through and you see the bottom. But if you look at a shallow angle, what you see is a reflection of the sky. So if light comes in at a shallow angle, it bounces off, and that can happen inside a crystal. So there's the reason that crystals are sparkly is that on the inside, light can come in, bounce off the inside, and then come back out in the direction that it was coming from to start with. And on the way, it might get split up because all the colours will get refracted at slightly different angles. So you also get a slight rainbow effect that gives you a sparkly colour on the way out. And when you get the shapes, if I'm not really into the details of cutting diamonds, but the reason they're cut, the world of diamonds has come up with very specific shapes to cut diamonds into, and they are the shapes that maximize this effect where light goes in and bounces off the inside and comes back out again. So diamonds are actually, they do it naturally because they've got super high refractive index, so it's easy to make this happen, but they are designed to make this happen.
Well, thank you very much, Caroline's daughter. I hope that answered your question. This is from Marnie, who's been a regular inquisitor. I think I'm not sure if she's turned 8 years old. She was 7 when she started sending us questions. Marnie's question today: she would like to know if any of the panel could go back and spend a day at any time in history when a scientific discovery was made. When would it be and why? So that moment, and I realise, of course, we can be quite broad on this. I know it's never necessarily a specific day. There is a kind of broad, but that moment, that sense of the universe changing for human beings with a new piece of a new theory or idea. Who would like to go first? Because I realise that's yes, Anne-Marie.
So mine is there's a woman I'm obsessed with called Gladys West, who was a mathematician in the US, and she is still alive. But she was one of the first people, or the first person, to kind of formalize the idea that you could use the satellites that we've got kind of orbiting around to help pinpoint where someone is anywhere on Earth. So she essentially wrote that initial maths paper for what we now have as GPS, or the blue dot on Google Maps, if you're that way inclined. Not incredibly useful for heading around the house, but in pre-lockdown life, if you're the kind of person that always gets lost, Gladys was the person that worked out the maths to know, here's where you are, and we're going to use these satellites to figure out where you are on Earth, the kind of triangulation that you've got behind that technology. So that would definitely be the day I'd want to go back to, just to the kind of well, if that's there and that's there, then I could know exactly where I am, because I'm always getting lost. And I thank her, give her a high five.
Isn't that it's such a so many of the names that I hear people mention, and I just think they're not in common currency, they're not in popular culture. And I always think it's such a sad thing where if an actor plays a scientist, they'll appear on Graham Norton, but if that real scientist was available, they would not be a guest. Someone pretending to be the physicist, the computer scientist, that's great. Gladys West, I'm going to find out more about her. Susie, where would you go back to?
I don't know who did this actually, but the thing that sprung to mind would be, I'd like to be with the first person that looked at deep images from Hubble. Where you look out into the universe and, the first time you see the entire zoo of galaxies in those images. I think that must have blown people's minds when they first saw that. And I don't know who the first person was to see that. So maybe that's something that, just imagine discovering that would just be phenomenal. I think, for a long time, we thought of our own solar system, we're the center of our own universe, right? And just to look out and realize, actually, oh my goodness, we're totally not. Must have been really amazing.
And you need to stare at that photo for a long time, don't you? I think, because it's very often used in presentations, and it does look like kind of sparkly sweets almost, just thrown up into a dark. And then the more you look, and the more you go, hang on a minute, that thing there, how big is that?
Yeah,
how many things are in it?
Yeah, exactly. I think it's mind blowing. Actually, it's mind blowing when I see these. I've seen them thousands of times. I still think it's amazing. So, yeah. That's
I've always found that it's like the cosmic microwave background radiation.
That's the other one that sprung to mind, actually. That was yes, those sort of, again, a bit of a light bulb moment, really, a bit of an amazing discovery that changes everything. Phenomenal.
And Helen, what about you?
So I would pick the research expedition where they saw the stripes on the toe. There'd been these ideas that continents might move, and a lot of people were like, nonsense. Right? What are you talking about? These are great big things with mountains. They are not going anywhere. Just go and do something sensible. And because, there were other coincidences that made it seem like it might happen, but no one could prove that it might happen. And then there was a cruise that went, so in the center of the Atlantic Ocean, where the plates are coming apart, they took magnetic surveys going across the crack, basically, and because the Earth's magnetic field reverses every few years, as the plates were coming apart, they'd record one way and then the next way and the next way, and they matched. They were symmetrical on either side. And I think the first person that, as that cruise data was coming in, and they could see the magnetic tape of the planet and say, this planet does move. This enormous structure is dynamic, and that as a moment that, completely eliminate. There was no question after that. Some people had thought that the Earth was dynamic, but after there were still doubters, and that was like, that's it. Our planet moves, and that, for me, humanity has had this constant sort of assumption, the arrogant assumption that Earth is as it is now and it can't ever change, which of course is at the root of climate change, that we can't possibly do anything because the planet is just too big. And that, so that would be mine. I would have liked to have been on that ship.
But mine was I just think those certain moments in those Apollo missions, certain moments of looking out of the window and going, oh, give me the camera. They are magnificent. Let's find out now. This is from 5-year-old Zachary. Susie, I'm going to start with you on this. Zachary would like to know, when are kids going to be able to go into space?
Oh, that's a great question. Oh my goodness. I'm hoping that so at the moment you can buy a ticket to sort of go to the edge of space with various commercial organizations, cost a lot of money, and I don't think kids are allowed. I think there's an age limit. So I think you have to be an adult to go. So yeah, a bit tricky at the moment, but I think that we're sort of on the cusp of this idea of people just being able to buy tickets and go into space, a bit like we used to jump on an aeroplane and go somewhere. And, now routinely we all do this. You wouldn't sort of bat an eyelid at jumping on a plane and taking a kid with you. And so I'm kind of hoping that as things move forward and these flights get cheaper and more available, it might be possible to take entire families on a quick trip up to the edge of space and back again.
Worried that I'd be on the wrong side. I remember I went on the Universal film studio tour years ago, and whatever was interesting was always on the other side. So I go, I'm on the wrong side for Jaws. Now I'm on the wrong side for the Bates Motel. And I imagine going, you got the slightly cheaper seats. You can't see Earth from that aisle. Aisle D. All right, that was a waste. This is another one for. It's great to have so many questions from 4 and 5 year olds. By the way, this is lovely. This is from Joe, who's age 4. This is for you, Anne-Marie. Joe would like to know, what is the best number?
Oh, gosh, I don't know. I quite like 1. Because so many things apply to 1, but that's a really boring answer to that question.
But it isn't that bit of why numbers become interesting, because there's a certain point where kids, I'm sure you've seen this, the moment they find out about Google Play, they find ways of throwing that into everything they can.
And all the zeros, yeah. I think it's, everybody has their own. I guess it's like saying what's the best food. Kind of tough to just pick one, or like asking a parent what's the best child. It's rather a controversial question to ask, but I think 1 is the best number because it's the exception in so many different places. But there's something nice about the oneness and the unity, and I like the number 1. But I don't know. What's everyone else's favourite number? Favourite and best.
Do you have a favourite in the way that when you're a kid, the first time you find out that the 9 times table basically goes into reverse? You get 18, 81, 27, 72, those there's certain things which I think lure people into ideas when they're given a pattern, as Helen mentioned earlier on, pattern seeking creatures, and sometimes and it just seems so wonderful, and it seems like it does have a certain magic quality to it.
So for me, it was 11, or it still is 11 that has that, which I guess you've got the ones in that again. But for me, it was 11 because it is kind of a shift of 1. So my 11 times table, I memorized it, and that was fine. It wasn't a big deal. But I think it's only, I can't remember how old I was when I kind of realized that actually with any number times 11, so kind of a 2-digit number times 11, you add the 2 of them together and you put that number in the middle and it's on the outside. And I think there's something beautiful, as silly as that sounds, there's something beautiful about that, just being a way that numbers can overlap with each other, and 11 being the magical number to do that. But of course there's all kinds of magic tricks and all sorts that you can do that's around the number 11. So I think the 11 times table might have been it for me. Fibonacci and the rest of them have never really done it for me, if I'm going to be completely honest. Sorry to anyone that loves Fibonacci out there. No, it's a controversial thing to say, and it's in nature. But 11, multiplying things by 11, bigger numbers, three-digit numbers, 4-digit numbers by 11, I've always loved those, if we're talking numbers.
And we are. This is, let's have C Shambles question. This is from last week. Lots of people during the C Shambles show spoke about how we know more about deep space than we do the depths of the ocean. Why is this? Surely both are equally difficult to explore, or is there some extra challenge with the ocean that I'm not thinking of? That's from Stuart.
Oh, this drives me mad. So this question, I was going to write something this week about this. Writing a pitch on this is the thing that was on my list for later today. And it is so that here's the problem with this question. There's a problem at the root of the thing that you hear people say, which is that we know more about the surface of the moon than we know about the ocean. And it is not true on so many levels. What you can say is that the moon is mapped to a higher resolution over all of its surface than the bottom of the ocean. But that makes it seem as though the only thing there is to know about the surface of the ocean, about the shape of the ocean floor, is that it's there. And there is this massive problem with, we have a colonial history of exploration being, I'm going to go there, I'm going to draw a map, I'm going to stick a flag in it, and then I'm going to clear off, and that's all I need to know. And that is not true. And we need to shift our concept of exploration away from stick a flag in it and clear off to understanding process. So there is a vast amount more that we know about the ocean than the surface of the moon, or the rest of the universe, actually. But there's vast amounts more to know because it's all about process. It's an engine that's doing things all the time. It's got life on all these scales. Anyone who wants to hear me rant about this can go back and listen to Sea Shambles. So well,
I'll tell you what we'll do. You can continue this rant after this for the Cosmic Shambles Patreon supporters. We're doing an extra. I wasn't certain what I was going to ask Helen, but it seems that this, I will only have to ask one question. I can then leave the room, return an hour later. She'll still be go away again, have a snack, whatever. So if you want to know more about this Patreon followers,
the short version is that the ocean is changing much more quickly. And it's doing more things. So there is more to study. But we do know more about the ocean than we know about any environment outside Earth. And that,
as a side note, we ask this question quite a lot at our panel events. We ask people, kind of panelists and the audience, if you could get down in a submarine and go underwater and explore, or get in a rocket and go to space, would you explore? More people do say that they go to space than they'd get in a submarine. And they always say it's because they can't swim, which I think is really funny, because the show that Suzie was on, that was part of the training. Was to do the underwater challenge. And
really have to be able to swim. Have to be an astronaut. Yeah, absolutely. Yeah, it's part of the training.
Can't get away from it. So learn to swim, folks.
That was true. Back in the 60s, inner space and outer space, because the ocean was known as inner space, were equal footing. There was an equal footing. Mm-hmm. And frankly, the only real difference is that the universe is transparent to visible radiation. So we can look out to it and to see. And I swear, if we could have a pair of binoculars that let you look down into the ocean the way you can look up into the sky, everybody would want to go to the ocean. And it's just that we're allowed to ignore it because we can't see it. So our brain just goes, oh, it doesn't matter because we can't see it.
Mm. Well, a bit of a redesign because I mean they always end up landing in the sea, or they used to. Certainly the Apollo missions and used to land in the sea. So that was the mistake, wasn't it? What you needed was it immediately to become a kind of Nemo-esque Nautilus. And so they go straight from one to the other, and then you go, Neil, you've been to the moon and you've been to the deep sea. Which one did you like most?
Well, that makes it like an obstacle course, though, isn't it? You're not allowed home until you've completed the course. You've gone down to the bottom of the ocean, you've touched the bottom of the Marianas Trench, you've been to visit a bit of coral, and now you're allowed to come back and claim your prize.
Buzz Aldrin's playing his Joker on this one, going into the ocean. So welcome to the extraterrestrial and undersea. It's a knockout. This is. I'm not sure who this is from. We don't have a name attached to this, but assuming it doesn't rain in space, open brackets, does it? Triple question mark, close brackets. What is actually meant by the term space weather? Suzie, space weather.
Yes. Yes. Yeah, so it doesn't rain in space, so that was right. But so space weather, this is what I study actually. So space weather is about understanding the interaction of the sun with the planets in our solar system, basically. And so the sun, we look out in the sky, and the sun is just a constant thing that's always there. And we can't really tell when we look at it how dynamic it is. But if you look at some images taken by some spacecraft, you can just Google them, you find lots of videos. What you find is the solar surface is hugely dynamic. So sometimes it's really quiet, sometimes there are explosions coming off the surface. There's lots of features that you can see on the solar surface, and they vary over an 11-year cycle. So the sun's magnetic field flips roughly every 11 years, much like the Earth does every few 100,000 years. The sun flips every 11 years, and that governs the activity of the sun. So it gets more active, and then it gets more quiet, and so on. And so we sort of live, I guess, in the tenuous atmosphere of the sun in some senses. We have particles flying off the sun, all the travel way past the Earth, way past Pluto, to the edge of the heliosphere. And these particles can sometimes be traveling really fast. They can sometimes be really dense. There's magnetic fields embedded in all of this. And we sit in this environment. And so space weather is about trying to understand what's coming from the sun, doing literally a weather forecast. So looking at the sun, seeing what's coming and trying to work out the influence it's going to have on the planets. And so for the Earth, for example, a nice thing would be that if you happen to be near the north or the south, you might see the northern lights, the aurora borealis or the aurora australis in the southern hemisphere, and that's caused by this interaction and the Earth's magnetic field. Less good things can be quite disruptive, so it can be disruptive to things like communications, power grids, damaging to astronauts. So there's sort of lots of reasons to study space weather. It can be the only good thing is the aurora, and there's lots of kind of issues around space weather and how it affects our sort of technology, damaging satellites and spacecraft and things like that. So yes, we are weather forecasters. Our weather forecasts are not as accurate as the ones that we have on the Earth, and we're still learning the processes. So unlike the Earth, where we're beginning to get a really good idea of how to do this weather forecasting, in space we don't have many data points. You know, we don't have much data. On the Earth, we've got all these stations all over the Earth's surface to measure and keep our models in check, using data to kind of nudge our models. With the Sun-Earth system, we've got like 2 data points. So, you know, there's a lot of variability in what we can see based on our observations, in essence. So it's still in its infancy.
Yeah, just mention again that next week's science Q&A, as well as Helen will be back with us, but we also have Heather Berlin and we have David Eagleman, who I presume probably has a new book. He does a fantastic, he wrote a brilliant collection of short stories as well as his books about the brain called Some. So David Eagleman is going to be also, as well as on science Q&A next week, he will also be our bonus Patreon only guest. And also a reminder, if you're not a Patreon supporter, but you do have a couple of quid or 50 pence spare, there's a tip jar at the bottom there, and we're going to share that amongst artists and art centres as well. Anne-Marie, this is a computer science question, and this is something I think people have become increasingly intrigued by. How many programs have passed the Turing test? So I suppose first of all, could you don't worry so much, because I realise that you could just make it up. You go 11, 1, or 111, and then we'll go, hang on a minute, she's only using her favourite numbers. That's a cheat. But I suppose first, the Turing test, can you give us some sense, for those who don't know, what is the Turing test?
So the Turing test, Turing Test, even named after a man called Alan Turing, who was a great computer scientist, is essentially the test to see whether it's a human being or a computer that you are talking to or communicating with. So that's the Turing test. We've got all kinds of algorithms now that you may have spoken to, from whenever you have to talk to the telephone and you have to say, kind of, if you've called your bank and you have to say what you're after and it kind of says something back to you, to those really annoying calls that we have now that you get through where they kind of pause and then start talking back after the time they think you might have taken to say something. So we've all got lots of different algorithms and technical things that pretend to be human, but the Turing test is is this algorithm, can it pass for a human being in terms of a conversation? So that's what the Turing test is. How many have passed it? I don't know. It's above 1, I believe. If we can use my favorite number, the best number. But yeah, we're getting closer to having more of them pass the Turing test. In recent times, kind of algorithms have become more complex. We've got better processing power. We're able to teach them more. There is a big tech company called Google who's working on something called Google Duo now. Actually, I think it is Google Duo that's surprised a lot of people when they demoed it. I think it was late last year, because it was able to call hairdressers and book an appointment on your behalf without the hairdresser knowing that it was speaking to an algorithm rather than to an actual a real live personal assistant. So we're getting there, and that's something that's raised a lot of concerns, actually, because you probably want to know. It should probably declare that it's an algorithm rather than asking it whether it's had a good day or anything like that alongside it. But of course, in terms of impersonating someone else is the other kind of impersonation is the other thing we're slightly worried about with them as well. But I don't know. I'm sorry, I can't give you a number. This is really frustrating.
No, that's like I think what it is more interesting. That's. I mean, Is there any way in terms of also tracking that, bots are such a problem on social media, and when there's a big political story, suddenly you will find out if you've tweeted anything popular about it, you'll be flooded by something which appears to be framed in very, very similar language. Now, is that likely to be something that has been automatically generated, or is it very often actually that there are so many people working in terms of misinformation and distraction that we just have these kind of farms which are basically bum, 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 there we go?
I'm laughing because I don't want to get too political. But we've had in the last couple of days a couple of human beings who maybe run this country who've been operating a little bit like bots, kind of giving the same message on Twitter in response to a rather big topic. But yeah, I think with bots, there's lots of work that's being done by people like the Centre for the Prevention of Hate. I think they're called CDAPH or something along those lines, looking at kind of what does a bot look like. It's often they tweet the same text as lots of other accounts. Often they don't have very many followers. Often their bio has been kind of put together algorithmically, and so it doesn't really make much sense. Interested in fishing for potatoes and love America, kind of thing that you sometimes get on bios.
Is there a word, Anne-Marie? Is there a word for a test tells you it's definitely a robot, like the inverse of the Turing test? You know what you were saying about the tweets. Is there a test is there a name for the test that says yes, this is if it passes this test, it's definitely a robot? I don't
know. I don't think so, and I think it's a tough one because you have people that are new to Twitter. You have people who don't have the best grammar. So it's a tough one to say that they're not a human being. You have people who join thunderclaps. You have people who, all work together in the same team and have been told the same thing at the same meeting, and so tweet it all at the same time. So I think it's a tough one to be able to say that person is definitely a bot. But there are kind of signs that you then end up seeing. I don't know that there's a name for the troll test, I guess. Google duplex. Sorry, Andrew's just sent me. It's called duplex, not duo. I don't think there's a name, but it is something that where at least the big tech companies are working harder to be able to tell and to be able to kind of clean these kind of bot accounts off different platforms. So Instagram does a sweep every now and then. Twitter does a sweep fairly regularly, but they still don't catch a lot of those kind of what we've come to call Russian bots. Or trolls who are tweeting out all kinds of different things. But yeah, sometimes human beings act together, so that makes it even harder.
Well, I can see why you were laughing about the last hours, because my theory is it's not that AI is going to improve, it's that humanity is going to go so far downhill that we'll just fail the Turing test. It will become, there will be massive, numbers of cabinet ministers and others, all of whom are failing that dismally.
I mean, we're living in a simulation anyway, so there we go.
Now we know it's all two-dimensional. That's taking a load off, isn't it, I think. By the way, if anyone does follow me on Twitter, just because, and I don't mind being political about this, I don't even think it is particularly political, really, but I did tweet something earlier on from my niece, who is a nurse who actually works with children with vulnerable health conditions. If you actually want to see what you are meant to do in that situation, I have something from the charity that she works at which explains what is really going on, so please do have a look at that. We're going to have to rattle through the last few questions, and then in a moment we're also going to have Andrew Holding's going to join us. I'm going to have a chat with him about a thing that he found in a recipe book, which is quite an intriguing story. Scott James wants to know, Scott James wants to know, why is the speed of light so slow? I've never considered it slow or fast. I don't know what. Again, the reference frame is problematic, I suppose. Is that part of? Helen, do you feel it is too slow? I mean, if you're tweaking the universe, is this one of the issues that might be tweaked?
Well, one of the interesting things that comes up is there are these fundamental constants, and the speed of light is one of them, where, we say, well, it just is that. And we think that there may not be a deeper reason. It's just this universe has that constant and that's the end of it. And there is this debate about if you had other constants, other combinations, then you wouldn't be able to live in this universe, because either gravity would be so big that everything would be a black hole, or it wouldn't be, there's all these other balances that go on. So it may be that gravity, it could be that you can only have life if, like, the ratio of gravity that to our perception that you need has to be like this in order to have life. So it's not a very satisfying answer, but I do think that if you tweak the speed of light by even a little bit, actually it has knock-on effects in all kinds of other ways, and the way that life might exist changes quite a lot. So there is this thing called the weak anthropic principle that says that the reason things are as they are is that if they didn't have these numbers, then we couldn't possibly exist to look at them. So we might be living in one of many universes, and we're the only one that's got exactly the right speed of light and all the other constants to exist. It's a hard question.
Well, I think it's really interesting actually when you start thinking about constants, because there are lots of fundamental constants in physics, and we have these numbers that have been determined experimentally in essence, and there are a large number of them, and there are lots of people who are out there trying to work out, actually, are they all fundamental, or from those you can derive others. So I think this idea is super interesting actually about what are the fundamental numbers in the universe.
Well, again, I'll mention the black hole show that goes out, I think, in just over a week, because it's one of the fascinating things, again, in terms of some of the fundamentals of the universe and what we've presumed are necessary are for black holes. To understand them, it appears that there may well be some fundamental ideas of physics which are going to have to be thrown out of the window. This is Danielle would just like to know. Danielle wants to be transported to a planet with more intelligent life than this one, please. We're going to be looking far off, aren't we? When you look up towards space, Susie, which of course towards space is in every direction, I suppose. But do you think, where, how far away could that signal be coming from when we finally pick it up?
Golly, that's a really good question. I think that one thing we have to think about is how long it takes signals to travel and how close and far away the nearest planets are. So think about the nearest stars, Alpha Centauri, Proxima Centauri. Light takes about 4 years to get here from there. But so that's the closest that anything could possibly be outside our solar system, in essence, a system where there could be intelligent life. That'd be 4 years. Probably, though, if you look out at the vast reaches of space, the probability is that any intelligent life is an awful lot further away than that. So the issue of whether it exists or not is really hard, because I believe probably somewhere in the universe that there is life of some description. I don't think our Earth is that special, although I love them both. And so probably it's out there, but it just takes so incredibly long for a signal to get to us. And space is just so vast that there could be somebody beaming out a signal right now. It wouldn't get here for another 12 million years. So that makes it quite tricky.
That's what I've always... That communication back and forth is, it's stymied, isn't it? Thank you so much, everyone. I'm going to join Andrew Holding, have a quick chat with him after we finish the Q&A. But that was great. And let's just find out, Anne-Marie, again, Stamets, where can people find out more, can get in contact, find out about the events, and find out whether they can manage to... Brilliant.
That's how you spell it. So it's got one M, because we've got maths, but not quite the medicine. And we're on Twitter, on Instagram. We're at the .org, we're everywhere. Just search for Stamets and you'll find us.
And remember, the first event after lockdown, the stack of vegan-friendly chocolate is going to be enormous.
Yeah,
it's going to be...
We've got them, yeah.
What a feast. What a rush of mathematical ideas there will be. Susie, where can people find out about what you're up to and kind of various different bits of research you're doing and anything that you're publishing?
Yeah, I'm on Twitter, so you can follow me. And if anything exciting happens, I'm working on a mission to Mercury right now. I often tweet about how far away is Mercury, what's it seen recently. So you can follow me there, or check out University of Leicester is where I work. So you can check out our web pages for news flashes on the things that we're working on.
Thank you very much. And Helen, you're going to be joining me again in about 15 minutes time. So for any of the Patreon supporters, I'm going to have a chat with Helen. Just mention before we go over to Andrew again, if you have questions about neuroscience, next week is a good week for that. David Eagleman, Heather Berlin, Helen will be with us again as well. So start sending those questions now, because I think that is, I enjoy doing every single one of those, one of these shows. But I really, the brain, I've been writing about that recently. It's just been very... so many things I want to know about this strange fist side thing that gives us curiosity, imagination, and all of those other problems that goes with it. So Helen, I will see you shortly. Anne-Marie and Susie, I hope to see you back when the world is more open again. Andrew, how are you doing?
I'm good, thanks. How are you?
Now, well, I want to get straight into this. Everyone loves the different Hollywood story that happens immediately. This, isn't it? It's it's probably got Sandra Bullock in it. Her grandmother dies. She finds a book. It has a recipe for a secret apple pie, and the story goes on from there. It's a kind of love story, and there's a scene at the end of a pier, all that kind of stuff. You have had a moment of basically, well, let's just say you found a recipe, didn't you?
Yeah, I did find a recipe. Probably one of the world's most secret recipes. And it was in my grandfather's belongings, which was quite a nice thing to find. So we kind of knew that this notebook existed. And he kind of said that, because it's my father who actually went through the things with me, that my father could have it. But he didn't hand it over before he passed away. So we ended up going through this suitcase. And to understand my grandparents' bungalow, they sort of half converted the loft. So the suitcase was behind the half conversion in the dark, going through these things. And we eventually found this little black moleskin sort of diary, and in it there was a load of lists of French words, and in the front it actually had the name Verrigan, who, if you don't know, is the sort of number 2 to Ernest Beaux, and Ernest Beaux was the guy who invented this stuff, which I don't know if that comes out.
Yeah, we can see it, yeah.
That is Chanel number 5 with a really nice crystal lid, if you go back to the earlier discussion. And that's amazing, because that basically meant we had this notebook that my grandfather had, which had the original formulas for some of the most famous perfumes in the world.
So did it have the mistakes? I mean, every now and again you see a crossing out and you go, oh yeah, that would have really stunk up the, I mean, what do you, by seeing these things broken down to their constituent parts, what do you learn about, I mean, there's that wonderful novel by Patrick Susskind, Perfume, which is all about that whole industry and the way that I think is probably towards the end of the 18th century, I think. But what does it tell you about what is required to excite our olfactory systems?
So, I mean, one of the key things is it's not written in a logical format. So you sort of go through, and to find number 5 is not like you go to page 5, which would have been really convenient. So you see them added over time, and you see them change. It's also worth realizing it's a working notebook. So it's the notebook my grandfather would have had, because he was working at the factory in Croydon, which was actually really important for making Chanel. Because of the little history of Chanel. Chanel perfume was made by Bourgeois, because that's who they sort of got contracted to do it. And of course, during 1939 to 1945, Parisian perfumery was not the best of industries. So most of Chanel number 5 was being made in Croydon. And my grandfather, what he would have done is he would have used this to make the perfumes in that factory. So they're making Soir de Paris, making Chanel number 5, making these really famous fragrances. But the other key thing that makes this very hard is you need an original copy of the perfume. And by that, I mean you need a bottle which will look something like this one here. So a brown bottle. And the reason it's brown is to protect it from the light. And the reason you need that is because the things that go into it are all natural ingredients at this time. And that means they change massively. So if you want to go and make one of these, like we actually went and tried to do, you may find that the smells have changed slightly. So you need someone with a really good nose and really good experience to actually correct the perfume back to what it's meant to smell like. So this is why it's really challenging for me. And this is what's quite impressive about my grandfather, was he had this honor of being the guy who sniffed the stuff coming out of the factory and checked it matched the stuff in the cabinet that Ernest Beaux said, now that is exactly what it should smell like.
So that is, I mean, he wasn't sniffing every single, but I presume there was a point where they go, that's okay, you've checked enough. So at what point would you have to, at what point in each day would it be, now it must be checked again?
I mean, these recipes are made in batches of about 600 litres, so he would have checked the batch.
Right.
And that would be the key thing. But he also would have checked the different ingredients. So we actually have an old BBC footage of my grandfather talking about this, and he used to be the guy who would go to other countries all over the world to buy things like ambergris and civet and these things that today presumably you can do using better logistics, but he would be the guy who'd have to bring it back. And for people who don't know, things like ambergris are just like giant lumps of whale vomit, and these are really important parts of making the base to your perfume. And he would have to go over and sniff it and work out what it is. And these things are not nice on their own. Civet is basically the smell of the back end of a cat. And And it's a really important base. And if you start talking to the people working on these perfumes, what they tell you is, well, you need to layer these tones up. So they talk about tones and chords, very musical. And these things he would be checking with these bass notes had to be exactly right. Otherwise, the whole thing is off. So yeah, he would have been doing it all the time. He also had to go to Ireland because there was a manufacturing island as well, and he'd be checking the smells there. So, and that was done much more on a batch sense. So they make up a stock and it will get diluted over there.
So
so I'm now a cancer researcher, but I originally started out as an organic chemist. And that was all about taking, in my work, natural products. So I was taking actually antibiotics, but could have been anything, and extracting them. And what you find that's very different between what I was doing in perfumery, you do in perfumery and what I was doing in the lab, was I try and get the exact molecule. Where if you take something like rose, which goes into loads of perfumes, you it's amazing what they do anyway. So if you want to make a kilo of the rose scent, you need about 250,000 roses. You then distill those down into a fragrance. But what you get there is you get different fragrances depending if you extract water, because they're sort of water-soluble ones, or if you use sort of oily chemicals to extract it, like we're not talking like vegetable oil, we're talking more sort of like the thinner oils, like more like petrol. You can get those sort of deeper smells out of it. So there's a whole solubility thing going on here about what different fragrances and what part of the plant. And then that leads us to when we get to more modern things and we want to try and bring in the synthetic compounds. And you go, well, what molecules in that make that smell? And you couldn't make a perfume with a strong rose base on those compounds I'm talking about because they're just so expensive. So what we do is we sort of get together the actual molecules that trigger the scents in our nose for rose. And there's sort of in the fragrances we're looking at, they talk about things called rose aroma, which is like a mini perfume made out of specific molecules that will always be the same. And that solves the variability, solves the cost issue because you can make it in a lab. And then you can top up with these other fragrances that have a more diverse set of music, as it were, because they pulled out all the other stuff. It may be a bit more variable because it depends how the season was when the plant was grown. So we have these two sort of competing sciences. You've got this idea that actually the diversity gives it a real beautiful interest for the observer or the smeller. But the chemistry, we can make very precise and very much control it. And I think that's a wonderful balance, and it shows how part of it's a science, precise and molecular, and part of it's sort of an art of how to make it smell really good. And I'm quite good at understanding the science. I'm not so good at the art side.
How much of a difference is there between Chanel No. 5 and Lynx?
Quite a lot in price, quite a lot in ingredients. And, it's interesting because when my grandfather was making Chanel No. 5, it was the thing the troops, often American troops, were buying in the stores to give to their girlfriends. It wasn't the way it's branded now, didn't exist. So it was a thing that a squaddy was buying. And that's more close to what we think of Lynx today than we do think of Chanel No. 5. The other thing is, Lynx will use a lot fewer natural products because they're expensive. So it will just be a very simple set of fragrances. But I think if you take that another step further, you think about Flash, the house cleaning product. I think you probably don't think there's a perfume in Flash. Probably don't worry about it. But when you're cleaning stuff, you want it to smell fresh. So someone had to make a perfume which works in Flash but also survives bleach. And I think that's a lovely thing. There you get the chemistry coming in again. You need something to survive these really harsh conditions and works in a modern day environment. So there's a whole host of fragrances out there. They have a massive influence on so many parts of our life. And then the field is constantly evolving. So the one we made for the show, so I've actually got it here, we made Soir de Paris. That formula has changed for other reasons. So if you were to try and buy a modern Chanel or modern fragrance, you couldn't use half the ingredients in that recipe, but because they're banned, they're animal products. So that means the fragrance I have in this bottle here that I made, the BBC, actually cannot be made now. So I have the last ever bottle of Soir de Paris ever made in the world to the original recipe, made by me, so questionably how good it is. And actually, we did get checked by a perfumer, and she made an interesting point, which it was different. But, and this brings us back to the thing you asked about the chemistry, perfumes mature. And that's because you've got these complex mixtures of all these molecules, which you don't necessarily know what all they are. They undergo chemical reactions. So when this was made and we showed it to someone a week later due to the sort of timescales of making a show, they're like, well, it's good. It's a nice fragrance. They like it. But it wasn't exactly like the standard they had kept in the Osmotek in Versailles, which is this place where they keep also all these different perfumes in like a wine cave. It sounds a lot more romantic. It's actually lots of brown bottles under argan. But when we compare the two, there was a difference. But that might just be because this is fresher and newer, and those chemical reactions haven't happened.
So where can people hear you talked about this story? They go and find this.
So if you want to listen to the whole journey, how we made this thing, it's on BBC Worldwide, Discovery Podcast. If you search for BBC Unbottling the Past, then you can follow the journey. And that goes for us finding this notebook, talking to my father. It's got archive footage of my grandfather. And we go through the whole process of trying to recreate this and getting it evaluated. And it was an amazing journey. Someone who's a chemist and sort of intersecting between that different world between, as you say, the molecular understanding biology and then trying to bring in how you actually make something that's a beautiful perfume.
That's brilliant. Thank you so much, Johnny. So I hope to see you back in Cambridge at some point doing another show and tell or similar. Thank you very much, everyone who's watched this or listened to it. As I've said, all of the back catalogue, not merely of the science Q&As, but also the whatever it was, 40, 50 shows that Josie and I did over the previous weeks with all those guests, and Mark Gatiss and Joe Brand and Sean McAuliffe and we had Reece Shearsmith, many different people. They're also all available as audio downloads as well. So we'll go and see there's about 4 different platforms you can find those on. Thank you very much, anyone who's been able to tip in the tip jar. I know that's not, a lot of you may not be able to or have tipped in the past, and that's absolutely fine. But if you can tip, that's fantastic. As I said, we share that out amongst artists and art centres. And thank you very much, anyone who is joining our Patreon as well. We're going to be making a few shows every single week. We basically, the more money that we raise, the more shows that we're going to be able to make. And we have a lot of fun making these shows. And we always talk to people with such interesting stories and ideas to share. So thank you very much. For those of you who are supporting us on Patreon already, in about 3 minutes time, I'm going to set Helen off on the inspiring rant of moon flag based information versus undersea flag based information. Thank you. And don't forget Josie Long, her show Tender, that's on tonight at 8:30. I'm sorry, I've just been told, by the way, it's not actually going to be live. We're going to record our conversation. The conversation with Helen will be available shortly after this, but we're going to have that chat now, and that is available to anyone, all the people supporting us via Patreon on the Cosmic Shambles site. So thanks very much, everyone. And also Wednesday, I'll be doing the I'm a Joke and So Are You show with a Q&A afterwards. And if you're Patreon supporter, you'll be able to see that. Whatever you can actually just get, there's tickets for £3 per household as well. If you want to see it, I have a lot of fun doing it, and I'll be talking about a lot of different things that I didn't talk about when I toured it as well. So thanks very much. Goodbye.